In this application, we're looking at the third scan on the and what this third scan is going to show us is the thickness of the polyimide material on this target wire. And so what we're using is the Acuity CL1 probe with an MG210 magnifier. And what this allows us to do is see that front face and the second face and do a differential measurement to calculate the thickness. And so here's that same area that we've scanned, 60 microns by 60 microns, and you can see we still have the two little areas that have a little defect in them. But let's go ahead and look at the scan, and let's go ahead and take a look at the 3D view. And you can see that we're getting pretty good results. And if we zoom this up, you will see that we have or it gets a little thicker on the edges, and I would expect that because as that confocal probe goes across it, we're going to be, the thinnest point should be the very top center here, right in this area of the measurement. So let's go back in and we'll look at the profile of this material. And here you can see we're doing a west to east, and we can pick where we want to scan. And as you can see, we're looking at that differential. Let's go ahead and pick it roughly about in the middle. And let's set this scale orientation to absolute. So this is showing us the thickness of that polyimide material from roughly 12 up to 16 microns in thickness. And here's roughly the center of that, and you can see it gets a little thicker on the edges. So as we can see with this white light confocal, it's doing a very good job in measuring the thickness. And one last thing, let's just zoom this up a little bit, see if we can get a better. So you can kind of get an idea. These are the roughly 1 micron steps that we're seeing going across that material.